Section 8.2 Interactive Assignment Objective 2. According to a study, the proportion of people who are satisfied with the way things are going in their lives is 0.88. Suppose that a random sample of 100 people is obtained. We're going to complete parts A through E below. First question is asking us, suppose the random sample of 100 people is asked, are you satisfied with the way things are going in your life? Is the response to this question qualitative or quantitative, and then explain. Okay, so here's the question. Let's go over the definition of what a qualitative and quantitative variables are. Qualitative or categorical variables allow for classification of individuals based on attribute or characteristic. Quantitative variables provide numerical measures of individuals. The values of a quantitative variable can be added or subtracted and provide meaningful results. In this case here, the response is qualitative because the responses can be classified based on the characteristic of being satisfied or not. So therefore, our answer is going to be part A. Now the next question says, explain why the sample proportion p hat is a random variable and what is the source of variability. So, explain why the sample proportion is a random variable and what is the source of variability. Well, here we have the sample proportion p hat is a random variable because the value of p hat varies from sample to sample. The variability is due to the fact that different people feel differently regarding their satisfaction. So therefore, it's going to be part C. Okay, now in part D it says, describe the sampling distribution of p hat, the proportion of people who are satisfied with the way things are going in their life, and then be sure to verify the model requirements. Okay, so let's go ahead and go to our question here. All right, so what we want to do is we first need to identify what is the sample size and what is the proportion in our question. Well, the sample size is given by 100 and the proportion is 0.88. So let's go ahead and first write that out. So we know that n is equal to 100 and the population proportion it's given is 0.88. Okay, now the next thing that we want to do is the following. Again, P is the proportion of people who are satisfied with the way things are going in their lives, and then we're going to let n be the size of the sample. For a simple random sample of size n with independent sample values and a population proportion p, the shape of the sampling distribution is approximately normal, provided the sample size is no more than 5% of the population size, and that n times p times 1 minus p is greater than or equal to 10. So, first thing we need to do is let's find the mean of the population proportion. So remember, the mean of the population proportion is equal to the value of the population proportion, which in this case is 0.88. Okay, now the next thing that we want to do is we want to determine whether it is approximately normal. So using the formula n times p times 1 minus p, we want to check to make sure that's greater than or equal to 10. So we know that n is equal to 100. We know that p is 0.88. And then we're going to multiply that by 1 minus 0.88. And we want to make sure that that's greater than or equal to 10. So let's go ahead and do that in our calculator. So we're going to do the following. We're going to take 100, multiply that by 0.88, and then multiply that by 1 minus 0.88. And that gives us 10.56. So 10.56, which makes that greater than or equal to 10. So therefore, it is approximately normal. And then the last thing that we want to do is now we want to be able to find the standard deviation of the population proportion. Now remember, the formula for that is taking the square root of p times 1 minus p and then dividing it by n. So we know that the population proportion is 0.88. We're going to multiply that by 1 minus 0.88. And then we're going to divide it by 100. and then take the square root of that value. And then we're going to round it to 3 decimal places. So let's go ahead and use our calculator. So my recommendation is when you do order of operations, do what's inside first and then take the square root. So in the numerator, we have 0.88, and then we're going to multiply that by 1 minus 0.88. Hit enter, and then divide it by 100. Okay, so now we're going to take the square root of this value. So we're going to take the square root, second square root of this answer. We can put in 0.0010560, and then press enter. Now let's round this to 3 decimal places, and we get 0.032. So we get 0.032. And so therefore we can answer the following. We can say that since the sample size is no more than 5% of the population size, and that the following is greater than or equal to 10, the distribution of the population proportion p hat is approximately normal, with the mean of the population proportion of 0.880 and the standard deviation of the population proportion to be 0.032. So let's go ahead and take a look here. There is our result. We have the following results. Okay, now the next question says, in the sample obtained in part A, what is the probability that the proportion who are satisfied with the way things are going on in their life exceeds 0.92? Okay, so let's take a look at that. So what does that mean? That means exceeds, meaning that we want to find out what is the probability that the population proportion is going to exceed 0.92, which means that we want to find, okay, the bell curve is the following. Well, we found the mean to be what value? Well, the mean is, from the previous step, we found that the mean is 0.88. And what we want to do is we want to find out what is the area that's to the right of 0.92. So we want to find the area here. Okay, so now what we want to do is we want to be able to find the z-score that corresponds to 0.92. So we know that x is 0.92. We know that the mean of the population proportion is 0.88. And we also know that the standard deviation of the population proportion is 0.032. So let's find our z-score. So z-score is taking x minus the mean of the population proportion and then dividing it by the standard deviation of the population proportion. So that means we're going to take 0.92, subtract 0.88, and then we're going to divide that by 0.032. And now what we're going to do is find that z-score. So using our calculator, we're going to do the following. We have 0.92 minus 0.88, and then dividing it by 0.032, which gives us 1.25. So we get a z-score of 1.25. So now in step 4, we know that the probability of finding the population proportion to be 0.92 is the same thing as find the probability that the z-score is going to be greater than 1.25. So drawing our picture, we know for the standard normal distribution, we know that we have 0 as the mean. And we want to find the area that's to the right of 1.25, which means that we need to find the area that's to the left of 1.25 if we're using the table. So we need to take 1 and then subtract whatever we get for the area that's to the left. So let's find the area to the left of 1.25. So if we look at 1.2 and then go all the way to 5, then we're going to see what we get for the probability that's to the left of that z-score, which is 0.8944. So we have 0.8944. So that's 1 minus 0.8944. Okay, so let's take 1 and subtract that. So if we take 1, subtract 0.8944, then that gives us 0.1056. So 0.1056. Okay, so that's going to tell us now that the probability that the population proportion is greater than 0.92 is going to equal 0.1056. Now, if we wanted to use StatCrunch, then we would do the following. We would say that 0 is our mean, 1 is our standard deviation. We want to find that it's greater than 1.25. Select compute, and you're going to see that we get the same area, which is 0.1056. Okay? And then if we wanted to use the calculator, then we would do the following. We would come in here and then select second distribution, go to normal CDF, and then our lower bound is 1.25, our upper bound is 9999 with a mean of 0, standard deviation of 1, and then select paste, and then you can see that we're going to get the same area of 0.1056. So we would say that the probability of the proportion who are satisfied with the way things are going in our life exceeds 0.92 is 0.1056. Let's go ahead and verify our results. So 0.1056, and there is our result. Okay, now the last question says, use a distribution for part C. Would it be unusual for a survey of 100 people to reveal that 81 or fewer people in the sample are satisfied with their lives? Okay, so let's go ahead and do that. So now what we're going to do is we need to find out what is the proportion for this. And what I mean by that is, okay, we need to find the population proportion of this example, which means that the population proportion is equal to x divided by n, where x is equal to 81, and we got to divide that by 100. So that gives us 0.81. So now what we want to do is we want to find the probability that the population proportion, it says fewer, it says to reveal that 81 or fewer. So what that means is we want to find this to be less than or equal to 0.81. Okay, so if we wanted to draw this distribution, well, again, we know that the mean from part C is 0.88, and we know that we want to find where it's less than 0.81. So we want to find this area here. And so what we want to do now is determine, okay, what is the z-score for that? Well, we know the value of x is going to equal 0.81. We know that the mean of the population proportion is 0.88. And we know the standard deviation of the population proportion from part C is 0.032. So let's find our z-score. So x minus the mean of the population proportion divided by the standard deviation of the population proportion. So we're going to take 0.81, subtract 0.88, and then divide it by the standard deviation of 0.032. So let's go ahead and do that on our calculator. So 0.81 minus 0.88, and then divide that by 0.032, which gives us negative 2.18, or 19, since we have to round it up. So it's negative 2.19. So now what we want to do is, in order to find the population, the probability of the population proportion is going to be less than or equal to 0.81, which is the same as find the probability that the z-score is going to be less than or equal to negative 2.19. So if we draw our picture, we know now that our mean is 0, and we want to find the area that's to the left of the z-score of negative 2.19. So let's go ahead and do that. So looking at our table, negative 2.19 gives us the following area, which is 0.1043. Okay. I'm sorry. Other way. 0.0143, I believe. Okay. And so now we know that we found that the probability that the population proportion would be less than or equal to 0.81 is equal to 0.0143. Now again, if we wanted to use our standard normal distribution calculator, the mean is 0, standard deviation is 1, and we want to find that it's going to be less than negative 2.19 for the z-score. Then you can see that's going to give us 0.0143 rounded to 4 decimal places. If we wanted to use our calculator, we're going to go to second, distribution, go to normal CDF. Now our lower bound is to the left of this, so now it's going to be negative 9999. Our upper bound is going to be negative 2.19 with our mean of 0 and standard deviation of 1. Select paste, and there is again our area, 0.0143 rounded to 4 decimal places. So therefore we'd say the probability that 81 or fewer people in the sample are satisfied is 0.0143, which is unusual because the probability is less than 5%. Putting in our answer here, the probability that 81 or fewer people, you can see that there is our result, and that concludes this question.